Hi, everybody. Mr. Wyatt here again, and we're moving on to section 2 of topic 7.5. We're going to be discussing angles today. We'll have a good amount of vocabulary again today, kind of like yesterday. Um, but angles, you've seen them before. You probably have an idea of what an angle is, and so hopefully this won't be completely coming out of nowhere for you. An angle, the best way to describe it is it's formed by two rays that both start at the same endpoint. I can see ray BA here, for example. And ray BA starts at point B, travels through point A, and continues on forever, indicated by that arrow. And then down here I have ray BC. Starts at point B, travels through C, and continues forever that direction. That common endpoint or starting point is technically what it is, but we call it an endpoint, is called the vertex. Okay, vertex. Uh, the way I always remember the word vertex is it starts with the letter V, and doesn't the letter V kind of look like an angle? So think of that point where the angle begins, where each side of the angle begins. That point right there is called your vertex. Now, a vertex is the point of intersection of two sides of an angle or a figure. It's the starting point where both sides begin. Okay, these rays are called the sides of the angle, just so you know. I have ray BA, I have ray BC. Those are the sides of the angle. If I want to name these angles, well, there are a couple of ways that we will name angles. Like this angle here, here's the symbol for an angle. Looks like an angle. I can call this angle ABC. Or I can call it angle CBA. We put the angle symbol down, and then imagine yourself tracing that angle, ABC, or the other way, CBA. That's angle ABC or angle CBA. It's the same angle. The only thing that matters is that the vertex, point B, is listed in the middle. Now, when you look at these angles over here, I have an angle right here, and then I have another ray that travels out here, kind of splitting that angle into two separate angles. I can call this one right here angle 1. I can call this one here angle 2. I really don't have any way to name this larger angle right here, unless you were to give me some more points. Like give me a point here, and then use that vertex point to label it. But I can call this angle angle 1, and I can call this angle angle 2. Okay, just using the numbers that are inside of the angle to name it. All right, types of angles. We have 4 types of angles. We have acute angles. Those are ones that are between 0 degrees and 90 degrees. A 90-degree angle looks like this. Okay, that's 90 degrees right there. And we represent it with a little square or a little box in the corner. An acute angle is between 0 and 90 degrees. Those are the smaller angles. They're less than 90 degrees. Aren't things that are small cuter? You look at that and you go, "Oh, that is a cute angle." I don't know why we think things that are smaller are cuter, but we always do. All right, so an acute angle is less than 90 degrees. It's between 0 and 90 degrees. A right angle is exactly 90 degrees. Then we have what's called an obtuse angle. Those are the larger ones. Like this here is a very large angle. It's more than 90 degrees. If it's between 90 and 180 degrees, it's called obtuse. And then we have one more that's called a straight angle. It's 180 degrees. This is a straight angle. You might think, well, isn't that just a line? Well, yes, but see this extra point right here? This is your vertex. Okay, there's your vertex. And that's what makes this an angle. Okay, and it is a 180-degree angle, which is called a straight angle. So acute angles, right angles, obtuse angles, and straight angles are the 4 types of angles. All right, let's talk a little bit more about lines now. We were discussing yesterday intersecting lines, and intersecting lines are lines that cross each other at exactly one point. So line AB, for example, this line right here, and line DE right here are intersecting lines. They intersect at point C. Okay? Now, if lines intersect and they form right angles, like line DE here and line FG here, kind of like those streets in Washington, D.C. when we were looking at that map of Washington, D.C. yesterday, those are special intersecting lines called perpendicular lines. Okay, they're just intersecting lines, but they form 90-degree angles. So line DE and line FG, for example, are known as perpendicular lines because they intersect, forming 90-degree angles. All right, so tell whether each angle is acute, obtuse, right, or straight. And I better clean this up a little bit. Acute, obtuse, right, or straight. Angle ACF. To find that angle, I know C is the vertex. Let's just kind of go to the picture and trace it. Angle ACF. All right, I just traced it, and it ends up being this angle right here. What kind of angle is that? Is it acute, obtuse, right, or straight? Well, it looks like it's less than 90 degrees, so that would be acute. That's an acute angle. Okay. How about angle ACG? I'll switch colors here. I'll go with red. ACG. Ooh, that's a different angle. ACG would be this angle right here. Now that one appears to be greater than 90 degrees. So we call that an obtuse angle. That's an obtuse angle. I'll switch colors again here. We'll go green this time. Let's find angle FCG. Well, here's F, here's C, here's G. Ooh, what kind of angle is that? Here's my vertex, point C. What kind of angle is that when it goes in a straight path? Ooh, I bet that's a straight angle. Oops. There we go. And finally, I'll switch colors here one more time. Oh, yellow is too hard to see. I'll just go with this color. I don't know what it is. Maybe I already used it. I don't even know. Angle DCG. Well, here's D. Here's C. And G is down here. Ooh. Isn't this angle 90 degrees? Right there? Yeah, this is known as a right angle. Okay, so acute, obtuse, straight, and right angles. You need to know all those terms. You also need to know that lines that intersect forming right angles are known as perpendicular lines. All right, now we can measure angles using a protractor. I won't have you doing that this year, just because it's hard to do that with the hybrid model, and especially for those of you that are at home all the time, you might not all have protractors. And I'm not giving you worksheets. Everything we're doing is in Google Classroom. But I just want to show you how a protractor is used. So I have a protractor here, and I have an angle over here. If I want to measure that angle, what I would do is set the protractor. There's a little hole in the bottom of the protractor right here. I'm going to line that hole up right on the vertex of this angle. So I'm going to slide it on over here, right there. And I want to make sure that this line on my protractor at the bottom here lines up with one of the sides of this angle. So I'm lining it up here well with this angle. And now how wide open is this mouth here of this angle? I'm going to try to move this a little bit better here and get it in better position there. That looks a little bit better. Okay, so if I go over here to my scale, I see 0 and I see 180. Which number do you think would be the number I want to use when I'm starting my measurement? Do you think I should probably start with 0? So I'm going to look at this inside scale, and I have 10 degrees, 20 degrees, 30 degrees, 40 degrees. A little bit more. Here's 50 degrees. This side looks like it's passing halfway between 40 and 50 degrees. And it is. So this angle actually measures 45 degrees. That's how we measure angles. We use degrees, okay? And just to give you a little bit better idea of what angles are just part of a circle. If you imagine an entire circle going all the way around here, I have to go off the screen here, and this is the center of the circle. If you go all the way around a circle, that's 360 degrees. So any distance that is not going all the way around the circle will be some part of that 360 degrees. This right here, this part would be 45 of those degrees. Okay? So that's all angles are. They are just parts of a larger circle. All right, perpendicular lines again are intersecting lines that form right angles, which are 90 degrees. Okay, so line AB and line CD are perpendicular lines. Do you remember how that differs from parallel lines? Remember, parallel lines never intersect. They're in the same plane. Remember that term, a plane? It's a flat surface that goes forever in all directions. If you have two lines that are on that same flat surface, that same plane, and they never intersect, those are parallel. They're always the same distance apart. Here's the symbol for parallel lines. You just draw a couple of parallel lines here at an angle. Okay? Perpendicular lines intersect and they form 90-degree angles. Here's the symbol for perpendicular lines. It looks like an upside down capital T. Imagine this segment and this segment are intersecting here and it's forming these right angles. So parallel lines, we use this symbol to show that they are parallel. Perpendicular lines, we use this symbol to show they are perpendicular. That's it. We're done with our lesson. Okay, so that's it for today. I will see you tomorrow.